So, so today's main agenda is to configuring and managing the virtual networking in vSphere environment. So, primarily we use networking for the host connectivity, virtual machine connectivity, so that the underlying virtual machine can talk with each other within host, or also they can talk to the machines those are available on another host, and also the physical servers we have into the environment. So there is two lessons we'll be covering: introduction of vSphere switches, standard and distributed, and their overview, and configuring the standard switch policies. All right. So what about the standard virtual switch? It will let us know identify the virtual switch, creating virtual switch, what are the different configuration available, and what are the different features at differentiation between a standard virtual switch and distributed virtual switch. Okay, so this is just a brief overview what a virtual switch is. Inside the ESXi host, a virtual switch primarily used to connect the virtual machines and to interact with the outsider physical network, like your physical switches or another devices that is available in our outside physical network. So provide connectivity between same ESXi host and also to the different ESXi hosts those are available and well connected to the physical network. They also support the VM kernel services. When we say VM kernel services, this is vSphere VM kernel. That is primarily the hypervisor function, not for your virtual machine. So they will use for vSphere vMotion migration, connecting iSCSI storage, connecting NFS storage, management network, vSAN storage, fault tolerance network. So these all are the VM kernel functions. So that all hypervisor VM kernel functions also being taken care by your virtual switch. Okay. So how virtual switch is different as compared to physical switch. So before I will walk to the virtual switch environment, let's talk about little bit about the physical switches. And I'm not taking any examples so far for ESXi, just talk about a simple environment. How do we do the networking in our data center between physical servers? Okay, just forget for some time. There is no ESXi, no VMware, nothing is there. So simple networking topology we typically create with two network switches, network switch 1, network switch 2, and these switches primarily use the physical port to connect the physical servers, and they also use the trunk port to connect the inter-switch connectivity, to make the inter-switch connectivity. Okay, so we always refer them as an uplink port, and the port which are connecting for switch we say them as an trunk port. Okay, so whenever we create a networking, like for example, this is my one server, this is my another server. Okay, there could be one server, there could be another server. So all my physical networking is based upon the networks we are going to use, the network segments and VLAN. So when we say VLAN is a virtual LAN, is a logical broadcast domain to segmenting your network environment. Okay, so for example, I would say I am using some of the servers for creating the database, like one database server here, one database server here. I have some application servers, app1. I have another for these servers are presenting application 2. These servers are presenting application 2. Maybe there is another application 3. Same way for here is application 3. Okay. So my workload is distributed in multiple network switches on the basis of requirement. So VLAN is primarily used for traffic segmentation. When we say traffic segmentation, to segregate the traffics from each other. Okay, like for I would say there should be a separate segment for the DB traffic. So what I will create a separate VLAN, like for example 101, to attach the DB servers. And also with each VLAN, we primarily use some of the network subnets associated with that particular VLAN. So there could be another VLAN like for 102 for application 1 servers, and the IP subnet we are going to use here 10.10.3.0/24. There could be another VLAN like for example 103 for app2 servers, and I am using the IP subnet 4.0/24 to assigning the IP addresses. So in this way, we can create number of VLANs for segregating the network traffic. Okay. So these all, like for an example, I will assign this port in VLAN 1, this port in VLAN 2, this port in VLAN 3, probably in VLAN 4. So in that way, I can segregate the VLAN traffic. So again, whatever VLAN design I will configure in my network switch 1, the same VLAN we have to configure in network switch 2 as well. But now question is arise, like for example, the same VLANs we have configured in network switch 1, the same VLAN we have configured in network switch 2. So how the VMs will talk, like for an example, the DB servers are belongs to VLAN 101, 101. My app 1 is connected to 102. My app 1 is connected to 102. Okay. So how they will talk with each other? So it is because of this trunk port. So what do you mean by trunk port? Trunk port always allow the available VLANs should talk with each other. So what we need to do from both the side, we will configure trunk port and we will give a list of allowed VLAN from here and same from here, so that this VLAN information can be synced between these two switches. Okay. And now my DB server can talk to this DB server. App server can talk to app server. App2 servers can talk with each other. Same way app3, app4 were the number of VLANs we have created. The VLAN to VLAN traffic can talk with each other, right? But if in case we have an environment where we wants to have a communication between VLAN 1 or another VLAN is 102. Okay, we want they should talk with each other over the network. So for that purpose, we have to configure the routing between these VLAN. Once we will configure the routing between these VLANs, it means that my DB servers will start to talk my app1 servers. For that, we require the routing. Okay. So that's how the basic networking and fundamental networkings done in the physical switch environment. Okay. All right. So now how my virtual switch is different as compared to physical switch inside the ESXi. Okay. So first thing is,
Sir, one question here.
Yeah, please.
Also, all this configuration is done by the network team only, right? Who is handling the
Correct.
switches and
Correct. This all
switches.
being taken care by the network team in case of it is a task of physical switches. Okay. But when we talk about virtual switch, that is something we have to take care ourselves. All right.
Yes.
So now, if we talk about the concept of virtual switch, first thing, virtual switch is not a physical device. That is a feature of your ESXi hypervisor. That's a software layer inside any of the ESXi you are configuring. Okay, let us suppose I have this host that I am using as an physical server. I have deployed ESXi, then that will have inbuilt virtual switch. Okay, so this virtual switch will have, like physical switch, it will have the physical port. Virtual switch will have the virtual ports. Okay, and how the virtual ports being defined there, to configure and to create the virtual port, first of all we have to create a port group. So port group is just parallel to your VLAN. So whenever we will configure a port group, we have to assign a name and VLAN ID as well. Okay, then let us suppose we have configured a port group DB server. So when we will feel I am launching a DB server application or DB server VMs, I will connect here and it will consume a virtual port. Same way if I'll connect here, it will consume a virtual port here. Same way if I'll create more DB, it will consume one virtual port here. So all the virtual machines where my virtual NIC will get connected to the virtual port available inside the port group. What is this? This is a port group. Okay. Same way, if I'll create another port group, like the name is PG app, something like that, PG app 1. So again, I will provide a name. Name is PG app 1 and I'll provide a VLAN ID as well. And if I'll create my application servers, again, these are the virtual servers. They will connect here and they will consume a virtual port. Same way, this could be another port group for another category of applications. So in this way, I will do the segregation or segmentation of my traffic. Like this is set of my DB server. This is set of my another application. This is set of my another application. Okay. So in this way, my DB server can talk to this DB, this VM can talk with each other. They can talk with each other, but they cannot talk with another. And there is no connectivity so far from outsider world. Okay. So as this slide is describing, virtual switches are not only for supporting the virtual machine traffic, also we can manage the traffic for the VM kernel port also. Okay, so VM kernel port is means these are used for ESXi on purpose. There could be one VM kernel port for management, could be one VM kernel port for vMotion, could be one VM kernel port for FT, could be one VM kernel port for NFS storage, could be another VM kernel port for vSAN. So whatever hypervisors on purpose, when I say on purpose, this is the is going to utilize them for its own purpose. So that is not a that will not use for virtual machine. These are the purposes of ESXi on functions. Okay, So we call them as an VM kernel port. Okay. So the VM kernel port also will have a name, ID, and also an IP address because it is an individual port. Okay. But port group, we cannot assign IP because inside a port group, there would be number of ports. But a VM kernel port is a individual port for particular ESXi host. Okay.
Sir, is there any number that we cannot assign like from 0 to 10, 20 to the VMs?
No, virtual port are dynamic actually. That's not a physical. The one once you will connect a virtual port get created, disconnect a virtual port will go away. Okay.
Okay.
It's
Okay.
dynamic, like it's not a fixed number available already.
Hmm. Like in VLAN, like we know that VLAN 0 is dedicated to someone, and then like there is a
So here also
uh,
we are giving VLAN, na? But only the difference in physical switch, there is physical port available and we have fixed those ports, correct? But
mhm.
here, these ports are virtual. Once you will associated a VLAN, a virtual port will get created. Once will VM go, virtual port will go. Got it? Clear,
Like
Pramod, or any doubt so far?
no, I have still one little doubt. Let's suppose we have a virtual switch, so
Ah.
we can create a port group inside to that virtual switch,
Mm-hmm.
and we can give like to the VMs. Those like let's suppose 5 VM, so all the 5 VMs will get the port group from that virtual switch.
Yeah,
Same
for
way,
5
the
VMs, 4 virtual port will be available there. These are the virtual port.
right,
If you will
and
remove any of the VM, this port will get free.
right,
Okay. So maximum number this virtual switch have, the port group is 1024 ports, virtual port. And those can be adjusted dynamically across the virtual port groups.
okay, 1024 is the maximum number.
Yeah, that you can adjust across
Mhm.
these ports, port group, but those are dynamic. These are not something like that. I have fixed it 500, 200, something like that. So it's on the basis of uses. Okay. So now how my traffic will go outside from this. So far one ESXi is looking good, but if side of this, I am planning one more ESXi with same configuration. So how these all things will talk to here, and again the same networking configuration I have done on secondary ESXi, how they will talk. So for that we need somewhere some physical connectivity. Okay. Same way here, when I say physical connectivity, we require the physical network switch. So this task will be yours as an vSphere administrator, but being as an network administrator, like for example, today you are saying, boss, to your network engineer, you told from the this virtual switch, my 6 or 8 VLAN will travel to these network switches. So that's the responsibility of a network switch administrator to trunk all the 10 VLANs for these ports from where your ESXi going to connect. So what it will do, he will trunk all the 10 VLANs to this port. He will trunk all the 10 VLANs to this port. He will trunk all the 10 VLANs to this port. He will trunk all the 10 VLANs to this port. Okay. Because if my traffic will travel across the physical switch, like for an example, this DB server wants to talk this DB server, this app server wants to talk this app server, this app server wants to talk this app server, and already those being have separate VLAN IDs. Like DB have again 101, 102, 103. Same VLAN should be available here, 101, 102, 103. You will assign to the port groups. In this case, you need to inform to your network admin. So this is example of two hosts. Probably there could be 10, 20 or 15, how many hosts are available in the cluster. Like for example, you are using 16 node cluster. In that case, you will consume 32 port. So you will tell to network admin from I want all these 32 ports you are assigning me from your network switch, trunk all my 10 VLANs to these ports so that my traffic go here and there. In future, there should not be any disturbance. So that would be task of your network administrator. All right. Are we clear? Or any questions so far? Parveen, Pramod, Hoshiar, are we good?
Yes, sir. Yes.
Be bit loud. I am not hearing you.
Yes, sir. Clear now.
You are clear, right?
Yes.
So now you understand the what is the task of me as an vSphere admin and what is the task of network administrator. All right?
Yes, sir. I got it.
Cool. Can I remove this slide now?
So we generally make the port group for the segregation purpose, like, right? Just like a
Yes,
VLAN.
network segmentation being achieved by creating the different port groups. So this is one example where it being stored your port groups, VM kernel port and uplink port. So when we say virtual machine port group, this is one example where we are going to connect my virtual machines. This is the dev and test. It means that this is another port group where we will connect the VMs that belongs to dev and test. So this is the port group name. Along with this port group name, you will also assign a VLAN ID. Then this is the DMG. This is another port group where my DMG VMs will get connected. Okay. Just one second. So same way, here also some VLAN ID will assign. Here also some VLAN ID assign. And just one example of VM kernel port, VM kernel port. So for these port, definitely there would be a name, purpose, VLAN ID, and also one IP address for each of the VM kernel port. What is the name? What is VLAN ID? What is the IP address? Because it's a individual port. It's equivalent to this port, but this port is being used for virtual machine. This port is being used for hypervisor on purpose. When I say on purpose means it's on purpose. So in this example here, for this virtual switch, 4 uplinks being associated. So means that is, if there would be some underlying physical switches available, then we have to design in that way. 2 will go here and 2 will go to another virtual switch. There could be 2 uplink as well. Okay. There should be another picture.
One question here.
Yes, yes, please.
If suppose there is multiple port group, there is multiple port group we created. So can we uplink one physical NIC to multiple port group? If suppose there is 5, 6 port
No,
group we
by
create.
default it is multi already, but you can ask a question. Can we map multiple uplinks to multiple virtual switch, single uplink? That's not possible. If in case, let us for an example, here is virtual switch 1, here is virtual switch 2. You just map this virtual switch to these two uplinks. So for these two virtual switch, I cannot use these two uplinks. I have to use another. Got it?
Sir, no, can you repeat again? I don't understood this.
Yeah. So like we have 4 uplinks in the particular ESXi host, where to virtual switch 1, I have associated with these 2 uplinks. Okay. Now all these port group can use them. Okay. No restriction to use them. But if I will create another virtual switch and integrate with my host, can I use these uplink that time? Answer is no. If there is a new virtual switch, there should be always new available port for map that. So we cannot map a single uplink with multiple virtual switch. There should be, if there is number of virtual switches we are using inside host, we need separate set of physical uplink ports. Got it?
सर थोड़ा कंफ्यूजन हो रहा है यहाँ पे.
Tell me, what is the confusion?
So virtual switch is we are creating a port group inside the virtual switch.
Absolutely right.
Okay, so we
My
cannot.
virtual switch will be mapped to the uplinks port, not the port group. Port group are inside virtual switch.
Okay.
So if, for example, like for this virtual switch, this one, the boundary one you are seeing here, I have mapped with 2 uplinks. If I am creating one more virtual switch in my host, can I map these uplinks? Answer is no. For a new virtual switch, we need the separate uplink ports.
Okay. Okay.
Got it?
Now clear. Now.
Can I map it here? Answer is no. If I am already using 2, I want to use these 2 are free. So these 2 free I can use for different virtual switch. Okay.
Okay, so clear now.
The same thing is coming in next slide, just next slide. Like this is single virtual switch with multiple port groups and multiple VM kernel port. But in this example, bottom one it is showing I am using separate virtual switch for separate traffic. But in this case, this is uplink 1, uplink 2, uplink 3, uplink 4, uplink 5, uplink 6, uplink 7, uplink 8, uplink 9, uplink 10. So what I mean to say that these are separate physical ports. Those are associated with separate virtual switches. All right. So we cannot reuse any of uplink port that is being already associated with one virtual switch to another virtual switch. Got it? Is it clear?
Sir, can we suppose, if we create a new virtual switch, or can we add that virtual switch to any uplink port? If we are creating
virtual switch always required uplink. Let me just give you one example on blank slide.
It will be like clear when we will do practical.
So
suppose sir, test environment, there is one uplink. Also management said just create a new virtual switch for test purpose as well. So can we
that
add
can
virtual
be.
switch?
Let's take an example. We have an ESXi host, correct? Now we have here 4 uplinks. Okay, these are my physical port going to underline physical switches. All right, like that way. These are my 4 uplinks. So now if you create one virtual switch, that virtual switch required some uplink port to take traffic outside until unless you will not take that. Okay. For example, here you have port group 1, port group 2, port group 3, port group 4. These are port groups. Okay. So definitely to take the traffic outside our world for this virtual switch, we need to map it. Okay. To my physical links. These are my physical links. is my uplink 1, suppose uplink 2. Now, if you are creating a new virtual switch for different purpose, that if you want the traffic should go in outsider world, there is number of port groups, then definitely required an uplink. But in that case, can I use these uplinks that is being already used? Answer is no. For a new virtual switch, we always required new uplink ports. All right.
Right, sir.
Yeah. Now you tell me your question where you have doubt.
Now clear, sir.
Clear? Okay. Okay. Fine. So the next example is about like when we were talking about when we are going to create any kind of port group or any kind of VM kernel port, that always required some VLAN. Like for an example, VLAN 105, it means that this VLAN 105 being given to a port group. This VLAN 106 being assigned to a port group. Okay. So when my virtual, this is very simple example here. It is my physical NIC, my virtual switch is mapped to my physical NIC. This is my uplink port. Okay. So wherever I am dropping this physical link to my physical switch, that port is called trunk port that I was told you in very beginning. So if I am bringing up here 5 VLAN 105, 106 by default, we have to tell to the the guy who is managing physical network, boss, all my VLANs should be trunked here where my uplink port is dropping. Okay. There could be another physical switch. There could be another physical port. So if it is dropping here, then all of the VLANs which are coming from the upper, it should be trunk. Now you can ask question, sir, why trunk is not required on hypervisor level on the uplink port? That is by default enabled. That is by default enabled already on my hypervisor. That's why we don't require a trunk to my ESXi ports. Only trunk is required. The VLAN we am sending outside, we have to inform to network team, boss, I am bringing up with these number of VLANs. Please trunk all to the ports where you have connected my ESXi hosts. All right. Clear? Any doubt? So when we say the type of virtual switches, we can create two types of virtual switch. One is standard, one is distributed. When we say standard virtual switch, that is always configured for a single host. What it means? It means that, like for example, in my cluster, there is 4 ESXi host. 1, 2, 3, 4. If for your ESXi host, I want one virtual switch. Let me make it a little bit bigger. There is 4 VM kernel port. There is 4 port groups.
So
So
first we make virtual switch. After that we have to make a port group, right?
yes, absolutely. So if in this virtual switch, let's talk. We are taking one example. We have to create 4 port groups for VM. Like for one is for prod, one is for dev and test, one is for DMG. And again, we have to create 4 VM kernel port, like for vMotion, for probably vSAN, probably for FT, something like that. Okay. And management, what is already available. Management is already available there. So in that case, if I need to make this configuration for my second host, so I have to repeat all these steps again here. I want same networking configuration on third host. I need to repeat, I need to repeat, I need to repeat. Because standard virtual switch configured on host level individually. But in case of, we talk about distributed switch that is being created on vCenter server level, and the distributed switch settings being reflected on all of the available ESXi host. So we don't need to create the separate configuration for each and every host. In case of we are planning for creating the distributed virtual switch. So for an example, if you say, sir, I have this ESXi, I have this, I have this, I have this. All of them are using two uplinks, two uplinks, two uplinks, two uplinks. So when I will create the distributed switch, it will create a, and also that distributed switch will define the DV uplink port. DV uplink port means is how many uplink ports it will use actually to connect with the physical switch. These are like they are consuming two uplink ports from each host. Okay, and on top of your network switch, these uplink will be again designed in the same way. One is with the like that. Okay, okay, let me take it like this way. So when I will create distributed switch, it will always create a hidden virtual switch that why I would say hidden in VM kernel port, but you cannot manage that from ESXi host. But yeah, definitely that will be reflected. Hidden virtual switch. Now, if under this distributed switch, I have created one port group, like for example, production VM. I have assigned VLAN ID 101. I have created another port group, test VM. I have assigned VLAN ID 102. I have created another port group, DMG. I have assigned the VLAN 103. So what will happen now? All these port groups you could see under all these four hosts. So it's make my life easier. Once I'll create DVS, I will associate the ESXi host with my DVS along with the uplink port. So whatever configuration I will do on my whatever virtual machine port group I will create on my distributed virtual switch, they would be utilized by the host. Those are the part of that distributed virtual switch. Let us suppose today I would say I am creating a VM here prod. I am creating a VM here prod. That's fine, no problem. You can create a VM under the prod port group from any of the host. And because this port group is visible for all the hosts. Same way, if I want to create some VM and I want to associate it with test port group, yeah, you go ahead on your host and these available port groups will be there for the all available ESXi host. So that's how distributed switches is pretty much helpful. We don't need to repeat all the configurations. Okay. Now, come on, sir, VM port group is fine. So what will happen to my VM kernels that I was using for like individually for each and every host? Let us suppose we have one management, we have one vMotion, we have one vSAN, we have one for fault tolerance, something like. Just for an example, there is 4 type of VM kernel port category available for each and every host. Okay, right? So how do we manage them in case of we are using DVS architecture? So for that, what you need to do, you will create a port group here for management traffic and assign the respective VLAN. You will create a port group for vSAN traffic. You will create a port group for vMotion. you will create one port group for FT. So in that case, what you will do is, now you will say, sir, can I make a single vMotion VM kernel for all? Answer is no. In that case, VM kernel port group will be created from the individual host, but they will be placed here. Like for example, today you say I have created one vMotion VM kernel. So that will be landed here in form of a virtual port. If you say one vMotion here, that will be landed here in form of virtual port. One vMotion, one virtual port. One vMotion, one virtual port. Same way for all the management, I can put the management here itself. Same way for FT, same way for your vSAN. So to managing the VM kernel traffic on DV switches, we will create the respective port groups, but all the VM kernel should be created individually for all of the EHXi host, and they will be landed inside my distributed virtual switch. Any questions so far? Are we clear on it?
Sir, one question.
Yes.
Sir, when we create kernel port in virtual switch level or in vCenter,
Host.
no, we have created kernel port in the host. So when we create kernel port, I mean,
Any kind of VM kernel port, like for example, you are creating here one vMotion VM kernel. Okay. Yeah, next.
and next we are creating second kernel port in the switch level. So you are linking in.
No. Don't need to create. Yeah, you are creating here. They will land here.
Okay. So in distribution switch, what we will create? So we have created one distribution switch.
Port group to land those VM kernel ports.
Okay. We will
Like
create
one vMotion port group, one vSAN port group, one FT port group, one management port group. Then you will create port here. It will ask you where you want to create. Like for example, you create vMotion. It will ask you the port group. Then you will refer this port group. If you are creating vMotion, vSAN, you refer this vSAN port group here. Then it will be created here. However, in a standard virtual switch, the VM kernel port group, VM kernel ports are individual ports. They will not land inside any port group. Got it?
okay.
Let me just draft one picture for you. A simple example. Just focus on VM kernel. Forget for a moment about the virtual machine port group, right? Let us suppose you have here two ESXi host and they have the standard virtual switch. This is the standard virtual switch in ESXi1. This is standard virtual switch in ESXi2. This is my standard VS. This is my standard VS. So what will happen here? For VM kernel's always the individual port.
So we create in the host.
Correct. We are creating host, but they are landing somewhere in standard virtual switch, right?
Right, sir.
Like one is management, one is vMotion, one is vSAN, one is FT. Okay. Same way, for second ESXi, you have to create their port, management, vMotion, vSAN, FT. Okay. This is my virtual switch. Okay. But they are independent port. They are not consuming any virtual port so far. Got it? And
Yes.
how the traffic will manage the outsider traffic again. This is because this is my virtual switch. So this virtual switch will be mapped to my physical uplink, and uplink will go to the physical network switch like that way. All right.
Right, sir.
Now, if I would say to you, I have the distributed virtual switch. Okay. So this distributed virtual switch will get created here. Now, forget for a moment, these are the standard virtual switches here. Forget it. Okay, let me draft another picture. Will give you more clarity in that case. So here I have one ESXi, here I have another ESXi. So here we are using the DVS, not the SVS. Okay. So that I told you, this DVS will create a hidden virtual switch inside each of the host. When I say hidden, you cannot manage it from host level. DVS will be managed only from vCenter server. Okay.
Okay.
So then you have defined two uplinks. That is fine. Okay. So two uplinks will be defined for each of the host in the DVS. So for DVS, for managing all these VM kernel level of management, we have to create the port groups, like this port group for management, this port group for vMotion, this port group for vSAN, this port group for FT. So what will happen in that case? You will say, sir, I am going to create a VM kernel port for vMotion. So this will be landed here. It will ask you what is the port group. If you are creating one for FT, like I have created for this FT, vMotion, sorry, vSAN, same way for management. So these all VM kernel ports will be the part of a specific port group that will be defined in advance in your distributed virtual switch. Okay, and instead of here, I was giving IP address, VLAN separately. I don't need to recap these things here because I have created a combined management port group. And for example, for management, we are using VLAN 0. So here I have to assign VLAN every time to this host, to this, maybe on third, maybe fourth. Same way for vSAN, same way for VLAN, vMotion, FT and all blah blah. But here I have created one port group, assign VLAN already. You will just create your VM kernel port, assign the IP address. They will be landed here. But how they will land it? During the port creation, it will ask you what is the port group name. So you will assign the port group. Clear?
Okay, sir. Clear now. So it will
Yeah.
ask. It will ask when we create the port group.
Absolutely. It will ask.
Which NIC you want to map this, or which port group you want to map.
Absolutely. When you are going to create VM kernel port and its functionality, it will ask you where you want to create it. Then you will define the port group name.
Okay, sir. So it will highlight and we will just select it. Right,
Yeah. There would be option of selection from the port groups. Then there would be drop down actually. Then you go ahead and select that.
Okay. So it will show all four two whatever in
It
our
will show you all the port groups. During the creation, even it will show you the port group that you have created for virtual machine. But you should be pretty clear because I have to use particular port group for vMotion. Then you just assign the vMotion port group because only that vMotion port group have the respective VLAN ID that you are using for vMotion purpose. You can map it at wrong place, that's fine, but it will not work.
Okay.
Purpose. Got it?
Yes.
And for standard switch, you have to create individually for each host, and every time you have to assign the VLAN ID and IP address. Here, you will assign the VLAN ID in advance while you have created these port groups. Well, simply, they are just behaving a virtual machine port group here. What you are doing, you are creating VM kernel and landing in these port groups. Okay. And the VLAN being assigned already. This is the difference between DBS configuration. So now, how my switch is being architectured into the VMware environment. So by default, each ESXi host built with each host have a default virtual switch. That by default, by nature, default virtual switch, by nature, that switch is standard virtual switch. Okay. And that have by identify virtual switch 0. And for an example, if you have 4 uplinks or 2 uplinks, something like that, it is always by default. It is map with your uplink 1. In VMware language, uplink 1 is vmnic 0. Okay. And a virtual machine port group is being by default created with the name of VM network. A virtual machine port group is by default available there. The name is VM network. A VM kernel port is already available. Name is management. Function is also management. Name is management. Function is also management. The very first IP, the day I was telling you, you will assign a IP address from DCUI console. That IP actually you are not giving to any physical port. Okay. That day, the management IP you have, this is my management VM kernel by default there. That day you are providing the management IP. It means that you were providing the IP address to this VM kernel port. And you remember there was a VLAN tab also in network configuration. So you were assigning that VLAN to this VM kernel port. By default, a VM kernel port being created there. Name is management, function is management. But like for initial configuration, you have to assign an IP address and a VLAN ID. So whatever VLAN ID you are using for your management purpose. All right. Clear? So that is the default setting. Now, if you will say, sir, can I create more port groups in this default virtual switch? Answer is absolutely yes. Sir, can I create more virtual switch in this environment? Answer is absolutely yes. But definitely you require some physical uplink port for mapping to that new virtual switch. All right. Sir, can I connect this default virtual switch to this NSV, new NVS? Answer is no, never. We cannot ever connect two virtual switches together. We cannot, we should not. Why? Because itself one virtual switch have lot of capability. You can add thousands of VMs, you can create desired virtual machine port groups and all. Okay. But still in worst case, you say, sir, no, I want some connectivity between this VS1 and VS2. Yeah, that is possible. But how? It will use some uplinks. It will use some uplinks. There is your network switch available. If you say, I want a communication, a VM is hosting here and a VM is hosting here. Yes, that is possible, but that is possible through these network switches. Okay, through these network switches. All right. My communication will happen between, can be happen between multiple virtual switches, but that is through the underlying physical switches. Two virtual switches directly cannot ever talk. Got my point? What I trying to say? Are we clear?
Sir, can you repeat please this one? I was just away.
I say two network virtual switch cannot be directly connected within a host. So if we want a communication between the VMs are hosted on these, that will be happen through physical network, not directly within hypervisor host. All right.
Right, sir.
So this is just telling you the steps how to add the host or how to create the switches and how we are going to configure the uplink ports. So from here, from this picture, you could see this host have two physical uplink ports. Correct? These are two physical uplink, and by default, those are connected to vSwitch 0. vSwitch 0 is my default virtual switch always. What is the speed? Is 10 Gbps. Well, this is the diagram of DVS where you could see the difference between a standard virtual switch and DV virtual switch. So what it's trying to tell you, we have created DVS on standard virtual, on vCenter server level. That DVS will create a hidden virtual switch in each of ESXi host. In this example, we are taking 3 DV uplink port. DV uplink means how many uplinks these switches will use to connect with the underlying physical switch. So these are the three. These are three. Okay, these are the three. We are mapping like that way, like that way, like that way. So these three physical ports will go to underlying physical network switches. Okay, so now if you go ahead and you will create, he took some example about distributed port group. So this is the these ports are primarily used for virtual machine. These primarily for management port, probably from this host. vSphere vMotion port for this host. Same way for host 2, there is some VMs are running on host 2. This is the management port and this is the vSphere vMotion port. Okay. So if I would say in another language, for these all setting, what distributed switch have been done, there is being one port group created. For that port group, these two ports are the member of that port group. If I'm talking about management, same way, there is another port group where members being defined for vMotion. There is another port group where all my VMs being defined here. Okay. So for each type of traffic, whether that is a type of virtual machine, there is separate port group. Whether that is management, there is separate port group. vMotion, there is separate port group being configured on distributed switch level. Okay. Are we clear? Any doubt or any question? Pramod, Praveen, are you there?
Yes, yes.
Clear?
Yes, sir.
Yes.
Okay. So somewhere you guys just ruined my slides. Huh? Like this. Okay. Probably I will, because these are shared. So these are some functions and feature differences being compared with VDS and the standard virtual switch. So I'll stop for today, and tomorrow onwards I will let you know the features differences and some of the networking policies, how we can configure on switch level. Okay. All right.
Right, sir.
Sure, sir.
Okay, then I'm stopping the recording for today.